NASA's Voyager 1 is sending mysterious data from beyond our solar system. 9 billion leagues away, its voice is clear, but one system's story doesn't add up. The Attitude Articulation and Control System, AACS, keeps the high-gain antenna locked on Earth. It orients the 45-year-old explorer, steering with minute bursts of thrusters. Voyager 1 executes commands and returns science data normally. Yet AACS telemetry appears invalid, sometimes random, sometimes impossible. The signal hasn't weakened. That means the antenna likely remains precisely aimed at Earth. No fault protection has triggered. Voyager is not in safe mode. Only essential systems are not enforced. Engineers are tracing the path of the data. Is it the AACS itself, or the chain that packages and sends its readouts? Voyager 1 is 14.5 billion miles, 23.3 billion kilometers, from Earth. Light takes 20 hours and 33 minutes to cross that gulf. Roughly 2 days pass between a command and its response. The mission team has trained for this rhythm for decades. Suzanne Dodd, Voyager project manager, says, "A mystery like this is sort of par for the course at this stage of the Voyager mission. Each spacecraft is nearly 45 years old, far beyond original plans. They fly in interstellar space, a harsh, high-radiation environment. AACS measures attitude and fires thrusters to correct drift. It keeps the high-gain antenna locked to the deep space network. Telemetry shows states that cannot be real. Values look randomly generated, yet the spacecraft behaves correctly. No panic, just process. They will isolate, test, and verify, one hypothesis at a time. They will monitor the signal closely and determine where in the chain the invalid data originates. Until the issue is understood, no one can predict its impact on science returns. Voyager's unique vantage point is too valuable to risk. The journey spans generations. Patience and precision are the fuel. Voyager 2 continues to operate normally. 2 craft, 2 paths, 1 deep space network listening. They cross the heliopause, the sun's protective bubble, into interstellar space. Their data reshaped our view of this diffuse frontier. There are big challenges for the engineering team, Dodd says, but if there is a way to solve the AACS issue, they'll find it. This is the mystery, and the conversation continues at light's patient pace. First, confirm the AACS is actually controlling attitude. No signal loss. Antenna lock is steady. Second, test each step that produces telemetry. Sensors, processing, formatting, transmission, one by one. Possible causes include sensor drift, or a telemetry formatter glitch, or a data path routing issue. Every test command takes a day out, and a day back. Planning is meticulous, execution is patient. AACS health safeguards pointing. If it falters, science data and communication are at risk. The team can adapt, software workarounds, or switch to redundant hardware if needed. In 2017, primary thrusters degraded. Engineers revived backup thrusters unused for 37 years. And they worked. Dodd says they may adapt without finding the source, or solve it with software, or a hardware switch. Each year, power drops by about 4 watts. They've shut off heaters and subsystems to preserve science. No science instruments have been turned off due to this power taper. The team aims to keep both spacecraft returning unique science beyond 2025. Interstellar space is new territory for spacecraft. Radiation can flip bits, age electronics, confuse sensors. Here, telemetry says one thing, but physics, the unchanged signal, says another. Engineers can ask AACS to send known patterns, then compare what returns, locate the corruption. They can infer attitude from other instruments and confirm that control actions match expectations. Earth listens from 3 continents. Ultra-sensitive ears catch a whisper from interstellar night. If the AACS is the source, adjust software. If the telemetry chain is the culprit, reroute or reformat. Constraints are real: legacy hardware, limited memory. Every change must be simple, reversible, tested. Generations work side by side. They speak Voyager's language, carefully, clearly, slowly. If there's a way to solve it, Dodd says, this team will find it. Adapt if we must, solve if we can. Either way, the mission continues. Listening, learning, line by line. Voyager 1 left the Sun's realm in 2012, into true interstellar space. Only these spacecraft have sampled this region directly. They revealed the heliosphere's boundary is sharper than expected. They mapped changes in magnetic field, density, and cosmic rays. 14.5 billion miles. Humanity's farthest messenger, still calling home. Today, one column of numbers is the puzzle. Yet the antenna appears right where it should be, on us. Par for the course at this stage, says Dodd. A long mission breeds resilient habits. Power falls, about 4 watts each year. Systems sleep so instruments can keep working. The team fights for science past 2025. Every downlink, a rare gift from the edge. Voyager 2 is healthy, a vital comparison point. Twin perspectives refine the heliosphere story. Next steps, test patterns, cross-checks, route changes. Then wait. 20 hours out, 20 back. Voyager also carries a message, the golden record, a map to us, pressed in copper and care. If the anomaly's source is found, patch or switch. If not, adapt operations around the noise. Because exploration rarely follows a straight line, and yet, it moves. Further, still. For now, antenna lock is steady, but AACS readouts remain suspect. We do not yet know if this will shorten the science timeline. Only time and tests will decide. Since 1977, people have kept these probes alive. They translate distant whispers into understanding. Big challenges, Dodd says. Big resolve. Voyager has met both before. On Earth, dishes wait at the edge of silence, tuned to a thread of energy from the dark. Out there, a small machine turns its face toward home, making minute corrections, still on course. A blue dot listens. A distant pixel answers. Until the mystery is solved, the conversation goes on. And with it, our reach into the interstellar night.